Alright, so now we're going to have a look at another ordinary differential equations question. Ordinary differential equations. So this time we're going to be having a look at an integrating factor question. So this is going to be an integrating factor question without an initial condition. So we are going to attempt question, so our question will be y prime plus 2xy is equal to e to the minus x squared. And so in this question we need to find a solution, we need to find a general solution, a solution in terms of y, so in terms of x, so y equals something. Now this question is not easily separable as the last question was. So this question is actually of a very specific form. It is of the form dy dx plus p of x y is equal to q of x. In our question we have p of x is 2x and we have q of x is e to the minus x squared. So we have a p of x defined and we have a q of x defined. In the case where we have this kind of differential equation, this kind of first order differential equation, we can find something that is known as an integrating factor. So the integrating factor I is equal to a constant, which we'll call a, times e to the integral of p x dx. So we're going to find these integrating factors and then we're going to use the integrating factor to find a solution. In fact, the solution will take the form y is equal to 1 over the integrating factor. Now I is a function of x, so the integrating factor is a function of x, multiplied by the integral of ix times qx dx plus c on ix. So this will be the solution form for this particular type of equation. We have to use the fact that there's a px and a qx to find the integrating factor, put the integrating factor into our solution formula, and this will give us our solution. So let's get started. So we're going to find the integrating factor first, if. So this is equal to some value a multiplied by e to the power of 2x dx. And this is an integral. So this ends up being equal to a times e. Well, the integral of 2x is x squared, e to the x squared, plus a constant, which we'll call c. Now, e to the x squared plus c is the same as e to the x squared times e to the c. E to the c is another constant. We already have a constant a out the front, so this will actually be equal to some other constant b times e to the x squared. We're essentially letting the c equal 0 because we already have a constant here. We're not letting c equal 0, we're imagining that the c and the a are incorporated into one constant. So we get our integrating factor I of x is equal to b times e to the power of x squared. So that's our first thing. Now that we have our integrating factor, we can plug this all into our solution. So now we can solve. So we have y is 1 over this, 1 over b e to the x squared times the integral of b e to the x squared times q of x. Now q of x is e to the minus x squared, e to the minus x squared dx plus a new constant, which we'll call c, over b e to the x squared. Now, e to the x squared times e to the minus x squared, this is e to the 0, so this is 1. So here we have b on b e to the x squared times the integral of 1 dx plus c over b e to the x squared. These b's cancel. The integral of 1 is just x, so we are going to get x on e to the x squared plus c on b e to the x squared. But the ratio of c and b, that again is just another constant, so we can just call this d, a constant, over e to the x squared. We can combine this. This becomes x plus d over e to the x squared. And this is our solution. Now this is another one. Now that we're at a slightly higher level of working, because these are university questions, this is no longer schoolwork, you have to be much more precise here. So we actually want to check this. So we are going to check, we hope that once we differentiate this function, plug it all in, both sides will be equal. So we've just discovered that y is equal to x plus some constant d over e to the power of x squared. So this is a quotient rule. This is u, this is v. So u is x plus the constant d, u prime is just 1. V is e to the x squared. V prime is 2x e to the x squared. This is essentially a chain rule. So now we just want to confirm. This. So we have e to the u would become e to the u. Yep. So this is right. So now for our quotient rule, this will give us y prime is u prime times v minus u times v prime. U prime times v is e to the x squared minus u times v prime, which will be minus x plus d times 2x e to the x squared, all divided by v squared, which is e to the x squared squared. We're just going to leave it in that form for the time being, as e to the x squared squared. Now this plus 2 times xy is apparently equal to e to the minus x squared. So we have this. Now can we simplify anything here? We can factor an e to the x out of the top and cancel it with e to the x squared out of the top, cancel it with 1 from the bottom. So this becomes a 1. This becomes a 1. This squared cancels. So we're left with 1 minus 2x times x plus d over e to the x squared. So this is our y prime term, plus 2 times x times y. So plus 2 times x, and then y we just found was x plus d over e to the x squared. Now we need to simplify this, and this needs to simplify to e to the minus x squared. If it does, then this answer over here is correct, and then the question is finished. So let's do some bracket expansions up here, and then put everything over a common denominator. So this becomes 1 minus 2 x squared plus 2 dx plus 2x squared, and now we have plus 2 dx, and this is actually a minus because we have a minus 2x times both of these. Both are positive, so minus 2x squared minus 2dx. Essentially, we're looking for these to cancel. So when you're doing this working, look at those signs as you're going along, right? Because it's very easy to lose or gain a sign in these types of questions. This is all over e to the x squared. So we have minus 2x squared plus 2x squared. We have minus 2dx. We have plus 2dx. And this is equal to 1 over e to the x squared, which is e to the negative x squared. And this is the right-hand side, e to the negative x squared. This is the right-hand side. So our check worked out. We can be very comfortably certain that this x plus d over e to the x squared is in fact the general solution to this particular differential equation.